We're talking about a world where artificial intelligence can now taste and feel. A world where it can perceive its environment with an uncanny, almost human-like accuracy. And believe me, it's got people wondering, just how far will this go? In the blink of an eye, AI has gone into overdrive. Google Photos, that little app on your phone, is getting mind-blowing new AI tools that transform your static snapshots into full-blown dynamic videos. Meanwhile, Google DeepMind just unleashed a powerful new toolkit for building real-time AI systems, pushing the boundaries of instantaneous interaction. And it doesn't stop there. Meta, the company behind Facebook, has trained a colossal, atomic-level AI model to dramatically speed up chemistry research. But perhaps the most unnerving development? Researchers have invented a graphene AI tongue that can taste flavors with nearly human-level accuracy. Yes, you heard that right. An AI that can taste. Oh, and as if all that wasn't enough, Mark Zuckerberg is actively building AI supercomputers the size of power plants. Seriously, crazy stuff is happening right now, and we need to talk about it. Let's dive in. Let's start on the consumer side of things, because Google Photos is quietly rolling out a massive quality-of-life upgrade. If you've ever fumbled around that little plus icon trying to create a collage or an animation, you know it can feel a bit like searching for a hidden Easter egg in an old video game. Well, Google's streamlining all of those creative tools into one sleek, full-screen Create panel. It's been spotted in a test version for Android, and while it isn't live for everyone just yet, when it finally lands, everything will be right there at your fingertips. Imagine this: one-tap collages, quick animations, those flashy cinematic photos that magically fake depth and motion, and even short mashups that seamlessly blend still shots with video, clips. And here's the truly groundbreaking part. Because Google's entire push is AI first, two even heavier features are currently in quiet testing: photo to video and remix. These are the moments where Google's advanced image models do the real heavy lifting, generating entire video sequences or reshuffling your media with incredible style cues. The only thing strangely missing, at least in the test build, is the traditional album builder. For now, you'd still have to navigate the old way. Google hasn't locked in a release date, but internal signs suggest the rollout isn't far off. We're talking weeks, not months, once the company is absolutely certain these powerful AI filters won't melt anyone's storage quota. Now let's slide over to the developer corner, because Google DeepMind just open-sourced something called Gen AI processors under a very permissive Apache 2.0 license. This means anyone can download it and build on it. The core idea is deceptively simple. Keep every kind of data, text, sound, pictures, or even bits of JSON, moving smoothly and efficiently through an AI pipeline. Each piece of information is neatly wrapped in a tiny package, almost like a digital parcel, called a processor part. These packages travel in a single orderly line, powered by Python's efficient asyncio. And here's the genius part. Because every single step in this digital assembly line can start working, the very instant the first package arrives, users see the first words of an answer much, much sooner. Engineers call this a faster time to first token, and it's a huge deal for real-time responsiveness. This library plugs directly into Google's powerful Gemini family of AI models. It speaks both the standard request and reply interface and the incredibly fast Gemini Live streaming feed, meaning the model can begin answering even while you're still typing your query. To help developers get started, DeepMind even includes 3 brilliant demonstration notebooks. One magically transforms raw match data into live sports commentary. Another efficiently gathers information from the web and produces concise, quick summaries. And a third, perhaps most excitingly, listens to a microphone and answers out loud, opening up incredible possibilities for voice interfaces. While Google's GenAI client and Vertex AI handle the heavy lifting of actually running the models, GenAI Processors focuses entirely on elegantly organizing how information flows to and from those models. Other orchestration libraries, like LangChain or NVIDIA's NeMo, can do similar jobs, but they were mainly designed around single-direction text chains or large neural graphs. GenAI Processors, on the other hand, was built from day one for two-way, real-time streams, making it incredibly versatile. A community contribution folder is already rapidly filling with extras, with early additions handling content filtering and PDF slicing, so its list of abilities is expected to grow quickly. This is a significant step towards truly dynamic and responsive AI systems. Even the smallest publicly available version of YUMA can simulate 1,000 atoms at roughly 16 steps per second on a single high-end GPU. And remarkably, it keeps working with test cases containing up to a staggering 100,000 atoms. When the Meta team plotted computing effort against error, they discovered a neat, straight-line pattern. This means a clear, predictable relationship. Give the model more capacity, and its accuracy consistently improves. They also leveraged a mixture of experts approach, incorporating several specialized subnetworks within one larger, overarching model. Moving from one expert to 8 sharply cut errors, though raising the count past 32 delivered only modest gains. So, most published versions of YUMA sit near that optimal sweet spot. On widely watched benchmarks, such as Adsorb ML and MatBench Discovery, YUMA consistently matches or even beats models built for one specific task. However, it still has its limits. It struggles with atomic interactions that reach farther than 6 angstroms, and its fixed charge and spin categories mean it cannot yet handle values it never encountered during its initial training. Alright, prepare yourselves, because this next development is truly mind-bending. A research group has just unveiled what they're calling a graphene tongue, an artificial taste sensor that already clocks about 98.5% accuracy on flavors it has encountered before. And here's the really astonishing part. It achieves 75% to 90% accuracy on 40 completely new flavors it has never met. The hardware itself is incredibly clever. The team layers graphene oxide sheets, each just 1 atom thick, essentially carbon lattices dotted with oxygen groups, inside a nanofluidic channel. This channel precisely guides a tiny stream of liquid across the stack. As molecules in that liquid bump into the graphene, they subtly tweak its electrical conductivity in a signature pattern. Think of it like a highly sensitive piano. Certain molecules press specific keys on the graphene, creating a unique electrical melody. Crucially, the sensing layer and the tiny computer that interprets the signal live on the very same chip. This means data never has to shuffle over to a slower, external processor. That revolutionary design slashes latency and fixes a long-standing issue with older electronic tongues, which often choked on the frustrating delay between detection and classification. Of course, it's still a lab bench prototype. The current setup is bulky and demands more power than a mobile device could tolerate. The findings landed in the prestigious proceedings of the National Academy of Sciences, giving the work a strong peer review seal of approval. Yet, the authors themselves stress that a genuinely universal flavor sensor will need training libraries in the thousands of compounds, not hundreds. Until those broader benchmarks exist, the graphene tongue remains a proof of concept. But what a promising one. It pushes machine sensing a significant notch closer to true human perception. The implications are simply staggering. Now, while all this fundamental research is bubbling away, Meta is shoveling absolutely staggering resources into plain old raw compute power. Mark Zuckerberg announced recently that the company's first AI data center supercluster, codenamed Prometheus, is on track to light up in the year 2026 with more than 1 gigawatt of capacity. And another colossal cluster, Hyperion, is spec'd to hit a mind-boggling 5 gigawatts over several years. For context, a single gigawatt can power something like 750,000 homes. Meta wants that just for GPUs. Zuck openly says the firm will burn hundreds of billions of dollars in the relentless quest for superintelligence. Their capital expenditures alone sit in the $64 to $72 billion range for the year 2025. He's even personally inviting high-profile recruits, reportedly dangling a $200 million package at an Apple generative AI lead, and already signing former GitHub CEO Nat Friedman, plus former Scale AI CEO Alexander Wang. Internally, there's been some grumbling that their Llama 4 AI model slipped because the Delta Overlap 3 wasn't big enough. Basically, they needed more computational power. This massive supercluster push is the direct fix for that. Surprisingly, investors don't seem spooked at all. Meta stock closed just under $721 recently, up roughly 25% year-to-date. It seems the market is betting big on Meta's AI ambitions. But here's the unsettling question to end on. Something that keeps many people up at night. If machines can already taste, if they can create incredibly realistic videos, if they can simulate atoms with breathtaking accuracy, and if their processing power is scaling to the size of entire power grids, how long before they start doing things we haven't even imagined yet? How long before they develop new senses, new forms of perception, or even new ways of thinking that are completely alien to us? The line between human capability and artificial intelligence is blurring faster than ever before. We are witnessing the dawn of an era where AI is not just a tool, but a perceiver, a creator, and an accelerator of knowledge on an unprecedented scale. The implications are profound, exhilarating, and for some, deeply unsettling. What do you think? Are you thrilled by these advancements, or are you a little unnerved? Let me know your thoughts in the comments below. If you enjoyed this video and found it thought-provoking, hit that like button, subscribe for more deep dives into the future of AI, and as always, thanks for watching. Catch you in the next one.